just want to point out that finally, recently, this was always an important and delicate issue in IIT. We've been able to demonstrate that there is one way of measuring phi, in other words, intrinsic information and then irreducible intrinsic information, which is unique. In other words, it satisfies the postulate of IIT. It's directly derived from the postulate that I just mentioned. And it can be proven mathematically that that is the only measure of making a difference, if you wish, that does so, which is critical if you think about it, because obviously consciousness is what it is. It doesn't depend on how you measure it. And so must be the way we actually evaluate irreducibility in IIT. All of this leads to the fundamental identity of IIT, which I want to point out is an explanatory identity. From consciousness, we try to account for it in operational physical terms. And the identity says that an experience with all its specific integrated structure is identical in physical terms to a cause-effect structure, what I just showed you before, which is composed of distinctions and relations. The quality of the experience, the way the experience feels, should be accounted for completely by the distinction and relation that compose the structure, by its form, if you wish. And the amount of consciousness, the quantity of experience, is measured by phi, the measure of irreducibility, which is really a quantifier of existence. And there must be a one-to-one correspondence then between the properties of experiences and those of the corresponding cause-effect structures. So now let me just summarize all of this by saying that a cause-effect structure fully unfolds the causal powers of a physical substrate and a state. Think a bunch of neurons, some on and some off somewhere in the brain, based on that operationalization, which is the transition polarity matrix. And it does so at the optimal unit grain that maximizes existence, phi. It accounts then for the essential properties that are true of every experience: intrinsicality, composition, information, integration, and exclusion. And if the theory is right, it should account also for the specific properties of specific experiences with no further ingredients added. That is, for how space feels, time flows, and so on and so forth. In fact, this is very much the research program that is going on in the lab. It's been going on for a while. It's not an easy one, I can assure you. But the idea is to try to account from first principles for why space feels extended, time flowing, object as binding the general with the particular, and why colors and sounds and potentially in the end everything else feels that way. I will just mention, to give you a sense, how we can go about trying to explain the quality of experience. And we did that by starting from the experience of spatial extendedness, because it is pervasive. Almost all of our experiences are somehow painted, if you wish, in space, the canvas of visual space, but for that matter, the body also feels extended. Not all, otherwise it would be an axiom, but almost all are spatially extended. This is typically ignored, we take it for granted, okay? And that spatial extendedness, unlike other aspects of experience like a color or nausea or anything like that, is penetrable by introspection. We can, to some extent, understand the structure of spatial experience through introspection, which very much boils down to spatial attention in this case. The idea then is that we need to find a correspondence between phenomenology and the cause-effect structure specified by a particular substrate. We conjecture the right substrate is a grid. Here you see a 2D or a 1D grid of, say, neurons connected by lateral connection, not only. And then we unfold that cause-effect structure, and we should be able to account for the property of spatial extendedness. No further ingredients added, just the postulates of IIT. And so the phenomenological analysis, which for space is doable to some extent to introspection, identifies as basic distinctions for spatial experience spots, for lack of a better word, which are, any subset of the canvas of visual space, for instance, or body space that you can sort of focus on. And there are, of course, a huge number of spots of any size, any location in the visual field, for instance. And then 4 fundamental kinds of relations among spots. Reflexivity, every spot points to itself. Connection, every spot can have some other spot partially overlapping with it. That's a relation. Fusion, that two connected spot, well, you can always find some spot which is the fusion of the two. And finally, that for any spot, you can always find a spot that includes it or is included by it. These are really fundamental properties of spatial experience. I'll be happy to discuss that at some other level. But the key point here that I want to get across is then we take our conjectural physical substrate, a grid. Here is a 1D grid for simplicity. We unfold its cause-effect powers using just the postulates of IIT. We find irreducible distinctions, which would correspond to the spots, a particular mechanism, say D, E, two neurons, both off, that specify a cause and an effect that are irreducible, and relations among them. For instance, reflexivity means that a cause and an effect must fully overlap. Connection means that two distinctions partially overlap. So their cause and their effect are partially overlapping, which gives rise to a physical relation that can be measured also in terms of its phi value, its existence. Fusion, that you can take distinctions and you'll always find one that actually is the fusion of the two and vice versa. And inclusion, for every distinction, you can always find another one that either is included by it or includes it. So you do this systematically. Here you just see the few ones illustrated here, and you unfold this large cause-effect structure. And you can account in physical terms as substructures for the properties of spatial experience, including all those properties that follow from these four. These four, reflexivity, connection, fusion, inclusion, we call extendedness. That's what really makes space feel extended. But then there are derived properties, like you experience a region, and that regional space is at a location in space. This has a direct translation in terms of what is called the subtext and the supertext of a distinction. But it all follows from unfolding the cause-effect structure. The size of a spot, the boundary of a spot, or the distance between spots. Distances are available to us. We don't need to compute anything. They're all there among any spot in the visual field. All of that exists, so to speak, physically within the cause-effect structure. So obviously, I cannot hope to go through this properly. It's a long and dense paper, but I recommend that because you will find these things properly described and the correspondence properly pointed out. So with that, I want to then briefly go to the fact that as a scientific theory, IAT is actually testable. It has explanatory, predictive, and inferential power. To me, the explanatory power actually comes first. For something as fundamental as consciousness, you need to first try to account for many diverse and basic observations with a coherent theory. For instance, you need to account for why the cerebral cortex, or at least parts of it, is critical for consciousness. Other parts of the brain that are equally or more complicated, depending how you count it. For instance, the cerebellum has 5 times more neurons than the cerebral cortex. Why are those irrelevant for consciousness? You take out the cerebellum surgically, and consciousness basically does not change. Okay. Why are some parts of the cerebral cortex more important than others, as we will see? Why not cortical subcortical loops that are key for instance, allowing me to speak now and express what I want to express? But most of what's going on there, I have no idea. Why do those not contribute to consciousness? Why does consciousness vanish early in non-REM sleep, even though the neurons, as indicated here, continue firing at roughly the same rate as they do during wake? Or why does consciousness vanish during some seizures in which neurons fire more and more synchronously than during wake? You need to account for all these facts with a coherent theory. And I'll give you only a sketch here of the idea that purely based on the postulates of IIT, you can sort of already infer that a substrate like parts of the posterior cerebral cortex, where neurons are connected in a grid-like manner and then pyramids of grids stacked upon grids, is a very good substrate that, when unfolded, can actually specify a giant cause-effect structure. That is, high levels of consciousness, if you wish, of a certain kind. This is just an indication of the grid-like architecture of primary visual cortex, but that's true also in secondary and tertiary visual cortex. And here we see instead that for the cerebellum, despite its massive number of neurons, the fundamental organization of the cortex and the granule cells, Purkinje and the granule cells, is according to microzones, which are very much like parallel sheets, very modular, which interact minimally with each other. And that's a terrible architecture for having high phi. If you unfold something like this, you get many, many little mini entities indicated here, millions of them, rather than one big entity. Okay, so that explains why some anatomies are good and some anatomies are bad, at least in the brain, which is the only place where you can test a theory of consciousness. Now, on top of that, I told you that early in non-REM sleep, you lose consciousness. In fact, a third of the time or so early in non-REM, you are unconscious as much as we can tell. If I wake you up, you say there was nothing. The anatomy is still the same. So what changes? Where we know a lot about it, neuromodulators change, and what they do ultimately is probably by, making Martinotti cell burst. That's what we suspect based on various experiments with it. But whatever it is, the end result is that the causal interactions within posterior cortex are impaired. There are so-called off periods that break down the cause-effect power. So when you're awake, the posterior cortex can specify a giant cause-effect structure. When the same person falls into deep sleep early in the night, it's almost like the cerebellum. The causal interactions among neurons in posterior cortex break down also elsewhere, and then instead of one big entity, you fragment, you disintegrate, you decompose into many little things. That's sort of the explanation, and that explanation fits with evidence. This is intracranial recordings, intracranial stimulation, intracranial recording, which basically just look here. This is awake and conscious. This is in non-REM sleep early in the night and unconscious. And the response to the stimulus is strong, but in non-REM sleep, there is a period of reduction of the high frequencies here, which basically means that the neurons stop firing, then they come back, but it breaks down, this is the phase locking factor, it breaks down the ability of causes and effects to go across 200 milliseconds or so. So the presence and absence of consciousness in very basic cases can be accounted for in a coherent way by the principles of IIT, and hopefully also the quality of experience where we can study it. I showed you the first attempt, which has been that of accounting for why space feels the way it does, that the way it feels extended is a particular kind of cause-effect structure in the context of a much larger cause-effect structure of the experience. And we conjectured it's specified by grids. Grids do that, account for space, and only grids do that. I will not really explain this slide except for saying a grid-like substrate unfolded satisfy here in gold the properties of extendedness, those four properties of reflexivity, connection, fusion, and inclusion. And similar substrate in terms of number of neurons and connections, but arranged at random. Once you unfold it, you get distinctions, you get relations of some sort, but absolutely no extendedness. So you need a particular kind of substrate, a grid, to unfold into a cause-effect structure that accounts for phenomenal extendedness. And of course, roughly 38% we calculate of our cerebral cortex is organized in a grid-like manner. It's mostly posterior cortex is organized like that from V1 all the way up. And that is exactly what is needed for supporting an experience which is overwhelmingly spatial, like ours. There are experiments too, and there will be more, I hope, in the future, that indicate that these grids are important not just to process information as people talk, or they are important to see things. Here is an example of a lady that was studied by Marta Farah, in which before the surgery, she was asked to imagine how big a horse was, and in particular, when the horse would overflow her visual field, how close did it have to be? And she basically said 15 feet. It wasn't done just with the horse, it was done with all kinds of things. So that's how large her imagined visual field was, her spatial canvas. They took out one occipital lobe, and of course she became blind on that side, on that hemifield. That is no surprise. But also, importantly, when she tried to imagine after the surgery, for her space was basically half of what it was before. The other half did not exist. There is a full agnosia for space. And the horse would overflow her visual field when it was about 35 feet across. Okay, so this is just an indication that the lateral connections in our posterior cortical areas, according to IT, they're not just important for modulatory inference, some kind of fancy processing. They are actually there because they are what makes space exist for us.